Hi guys, so today I'm going to speak about the Transcan C, and I think it's a really cool mixture between a really professional structured light scanner and some good and easy to use concept like an Transcan SP. What is really uniting a little bit benefits of both kind of the devices, so you have a really accurate measurement and at the same time it's quite easy to use, and I think it will gain really market. It's a bit different to other brands. It might not be so far, I guess. Maybe this will change. The best solution for the DIY, do it your own modder scene. I think it's not so easy to change parts of the hardware, but I think it's not necessary, as it comes with a temperature compensated light crafter. That's not like a home projector and not having the same problems. It's just having one basic unit. That means where there is the digital camera signal united and bundled into one USB signal together with the projector. And you see here these cables. There is a second pair of cables, what is quite unusual in this price class. For most of you might not be clear what it means. It's a trigger cable, and this is the trick of the trigger. And what does it mean? This trigger cable synchronizes the shots of the projector with the capturing of the camera, and this will create the possibility of make the patterns very short. That means the projector will project a pattern very fast, and at the same time the camera will capture it. Most of the structured light systems, they are projecting one pattern for some milliseconds, some delay time, and the camera is capturing like a video frame, and this takes some time. So you will looking at an David SLS or so have a quite slow capturing. That means you will have a few, I would say second, two of capturing of one image, and you will see that this is not the case here. You will be really fast. Speed is not so far away from a handheld scanner, of course it's not, but it's much closer, and this really opens up a window to scanning a lot of products in very short time. So if you take out the Transcan C of its box, you have to first select your distance of the scanning field that you want to use. In this case, I'm using the most common one, that's the 300 millimeters. That's the width of the scanning field more or less that you will achieve, and I'm going from the transport distance or the initial distance, what hopefully will be another scanning field soon, to my destination. That would be 300, and I do the same on the other side. What is really nice is the aluminum billet profiles, and as well the quality of how these parts are made. It's all aluminum, and the finish is really well. I can afterwards adjust the angle, therefore I need to take off some integrated tools. They are fixed by magnets, and first I will have to find the center for the projector. That's the black cross that you see here, and this is quite fine. And right now I have to focus the projector first. That's my very first thing to do. I'm not doing this like described in the manual, because I think I can see it better on the backside for the white balance calibration. and you will see that if I'm going in the wrong direction, I'm losing focus. That crosses, they get more shallow, and if they get thicker and have a more contoured line, right now you see we have a really good focus, and right now we are out of focus again. So I'm using the position with the focus wheel on the projector, where I have the best and strongest appearance of the cross line in the middle. So that's it. The very first position is marked on this tissue that looks like a mouse pad that's included in the set from the scanner, and this is 1, 2, 3, 4 position. That means the amount of calibration steps that are here in numbers. And next thing that I will have to ensure is that the projector is in center with the camera centers, and as they are matching on the middle of the calibration board on an angle, it's important that they are doing that in the right distance. So using the manual, it will tell you something about 470 millimeters distance from the calibration board to the optical unit, more or less. So this is fine. I could go even a bit nearer. That's not something you have to take absolutely strict, because it's difficult to measure as well. And you see right now, here is the camera views. I'm just testing which camera I'm looking on. So this is the right camera, this is the left camera. That's really easy with your finger. And you see right now here, you see the red crosses from the camera midpoints. Of course you cannot see them on the calibration board because they are from the camera field of view and not projected, and they should match with the center from the calibration board in this position, what they are not doing in this moment. So I will have to turn them to the middle, mean that they are matching with the center of the projector. Therefore I'm going to open up that screws that adjust or that clamp that angle, fix them, and I'm starting to turn this into the center from the calibration board. And be careful that FPS frames amount per second isn't too high in the calibration mode, so do turns slowly, wait, readjust, wait, because it will take some time till it's shown on your picture. So that's fine for the right camera. Right now we are going to do the same for the left camera. And you see that I was turning too fast and just realizing it, that I'm too far after some times, because the pictures are actualizing slow. So right now I'm near the center. And I'm fine so far. This is fixed. I can right now leave the tool where it had been before, and I can close the camera protection plastics to be sure that nothing is harming them or hitting them. Okay, so we are done with the first step. Next step will be the camera adjustments regarding sharpness and aperture. And aperture is determination of the amount of light that's passing through to the sensor. That means this is like the diameter from the tube that permits a determined amount of light passing through, and if you are choosing a higher value for the aperture, that means that this diameter is going to be smaller and you have less light on your sensor, but you have as well another effect that you are having a little bit better depth of field in some range. So you are playing with many things at the same time. There is always the question how to start with this kind of the adjustments, and in my opinion the very first thing you should do is the camera aperture after the steps that I've shown you right now, because this have a very big influence on the range of object surface that you will be able to scan. So sometimes it's the best if you choose your object that you want to scan for this step. That means choose here the sensor sensitivity in the middle, that you have let's say way to go into the darker and the more bright direction. In this case of the Transcan, you don't have the projector brightness adjustable, so the only two parameters you have for determination of the amount of light that will be reflected and projected on the part is these two parameters. And I start here in the middle. As I know I have no special parts with special surfaces, it is a very good value, because in the capability of the system you are somewhere in some good neutral point. But if you would have, for example, a very dark part, it can make sense to right now put the dark part in front of your cameras that you want to scan later on. Adjust, let's say, that camera sensitivity here as parameter into the middle, and use the aperture to tune in to get some, let's say, good brightness level on the object. And for the calibration, you take off your part, put again the calibration board there, and then go up with the brightness, or in this case down, sorry, because your scan object is darker than your calibration object. You will have an overbright environment in this case for calibration, so you will have to go down with the sensitivity from the sensor. That means you will permit less light to be, let's say, used, and you will be able to calibrate anyway, so you will have a darker impression on the picture, but it will calibrate anyway, that's no problem. But you will have more room to play later on the scans. That means I will right now scan a sprayed part that's perfectly in the middle of the range from the surfaces that I could have, so no real issue for me in this case. I'm using the standard, I'm, let's say, using the calibration board level of let's say, what is here brightness, and this is the standard how you will do it, set it up if you don't know what you will scan later on, or you have a big variety of objects that you expect to scan. So calibration board, like it is described as well in the manual from Shining, is the best way to set up your brightness over the aperture. Okay, so in this case of the Transcan, it's different to most of the other systems in this lens. The aperture is not near the camera housing, it's the front ring to turn. That's to be, let's say, regarded if you have other systems as well. If you want to, let's say, adjust it, just don't turn the wrong ring. I think that aperture is quite well, because I already calibrated the system one time. Yeah, it looks fine. Actually, I'm in some good range here. Just expect that you will change the distance to, let's say, your scanning system from the calibration board. That will have a big influence on the amount of light that will be reflected. So the light density or intensity on your calibration board coming near will rise up very fast. That's not linear. So don't go to the very uppest level that you can have on brightness and sensitivity. Both sides should look similar. I'm just, let's say, going back on the other side as well. Because of the slow speed of image actualization, just turn in small steps, wait, turn, wait, and that should be fine. Don't forget in the end to tighten the screws that fix your aperture, because if you will later on after calibration change the aperture, your calibration is done. You will have to make a new one. You will have changed your optical setup and you will not be able to use it. So these two are done, and what rests is right now to adjust the camera sharpness. So you want to be sure that you have the maximum contrast visible from your megapixels that are available on your camera, and therefore it's like focusing a photo camera for taking a sharp picture. You have here the same issue. As Shining is suggesting to put something with writings in front of your calibration board to try to read it and see if you are in a sharp, let's say focused situation or not, is for me not so easy, because I have to use rather big letters to be able to see if I'm sharp or not, because I will not see anything in the other case. It's for me a bit, let's say, suboptimal. So I'm just using some old Siemens stars that I was printing on our old business. If you need some of them, just contact me. I have a bunch of them, let's say, laying around. So this is just stickers, and right now I'm just adjusting for the right camera. So the ring to the housing of the camera is the right one, and I'm just going the wrong direction maximum possible. So you see it's not sharp anymore. If I'm going into the better direction step by step, you will see that the visible white areas compared to the black areas will be more visible going deeper to the middle of your view. And if I go the other direction, I'm just going too much, you see that it's going unsharp again. So I'm going back and just in small steps, turn, wait, turn, wait, turn, wait, tuning in to get the best possible focus that I can see. Don't get, let's say, confused. The good thing about the system from Shining is that they made the possible range in focus very small, and the good thing is about it, you are really having small area where you could do something wrong. So I'm using that method that I was describing. Okay, so we are sharp right now. I take off that Siemens stars. So on the first step you are doing the calibration shot on the position I was showing you before. Its shot is just a turned calibration board for 90 degrees. This turnings into clockwise direction will continue for step 3 and 4. And after they are done, there's dislocating steps. Don't forget to go back to your initial position regarding the turning. This means this star that you can see has 2 points on the lower end and 1 point on the upper end. That means it should be 2 points on the lower end again and 1 upper, so you all know that you are fine. The next 5th step is described on that mousepad like surface where you have to put a calibration board, and it will be fine. I'm just going to use it like it's described. If you are sometimes receiving some message regarding calibration error or not completed calibration steps, it might be because of over brighten or under brightening some position in the calibration board. Then you will have to play with the camera sensitivity, what doesn't affect your preciseness and your calibration result. So you can do that, no problem. It would not be permitted in the case not. And it was step 7. Step 8. Step 9. For all of you who have ever operated an Arctic Spider should know that kind of the steps that we are taking. Step 10 will be the last one. That's the one in front. Capture. So you might have just a problem again in the step 10 if you are very near the projector because of over brightening. In this case you can just go down with the sensitivity of the camera and you will be fine again, just to be sure. You've seen it in the start, I was, let's say, a bit too dark in the first distance, and after I was rising up the sensitivity, it was getting better. If you have a calibration that was done successfully, you will receive a message with the amount of pixels that you had as deviation, and right now I am just, let's say, able to calibrate the white balance. That's a very important step if you want to scan texture with color. Let's say you want to see your surface color, and if so, it is important that you are here selecting, if you're using a light box, that means some light box from photography that's surrounding your scan environment with the object that you are scanning. I'm not doing this here right now. You can as well then here activate real-time color effects. I will do another example on that. I will not use that right now. I'm just doing it how it had been standard. Therefore, don't forget to go back into your initial position for the calibration board and then turn it around as it's shown on your screen example to the right side of the calibration board, and you do white balance tests. That means that is a, let's say, a one-point calibration for the RGB colors. Everybody of you who had let's say design topics know what it means, and this means all your RGB channel over the white light is, let's say, balanced to one point where it's right. That's not, let's say, the perfect only condition to scan real life colors, but it's a very important one, and it's, let's say, something that should be in all professional scanners for the topic should be done. So I'm finished. I can quit right now. What I wish to be implemented in the next versions of the software is bigger fields for the preview of the camera. There would be really some benefit in the case that you would have a faster actualization speed between both cameras as well in this case, and in the case of making adjustments. And it would be really good if you had, for example, on the back side a distance, let's say, mark that is matching with a distance mark that can be two, just, let's say, small lines up there on the camera cross, because it will tell you how far or how distant you are, in this case close to your system, and you would be able to perfectly adjust it without using some kind of measurement stick, and it would be fine. But the rest is okay. So we are going to finish and start to scan. So we will scan a test part. We will replace the calibration stuff with the turntable. I got to say, this is the best part of that setup. I really love to scan with the turntable. It's a really good combination of a professional structured light scanner with a professional light crafter, not like a standard home projector, industrial cameras with a good standard. And on the other hand, the usability of an iScan SP or SE that is really easy to use, and merging everything automatically with no manual additional things to do. And so let's see how it's performing. Entering in the scan menu, first thing that we should do is to adjust our brightness level. I prefer to go in the upper area of the brightness level. That means I have some small overbrighted area, but I have most of the background of the part in good conditions. I go to high resolution because I want to see everything on the cast details and so on, even if it takes me more data. I'm using a turntable here in this case. I will do feature-based alignment. That means that each scan that will be created will be merged with the previous one based on its geometrical features and matched together. 12 steps is a good value for a more or less complex part. You can go up and down. They will be all, let's say, similarly be incremented. You can speed up or speed down the turning, but for this it's absolutely fine to use standard values. That's the most important things you have to know, and just press the button. Enjoy the amazing speed of scanning that is possible because of the synchronization between projections and cameras, and just go and have a coffee. so nothing to delete, everything is absolutely cleaned up. If so, you can have the same tools that you know from my Transcan HX videos in cleaning up scans, for example. If you need it, just take a look there, but it's absolutely perfect. If you have not aligned scans, there is the same tool here, align, like you know it from the other shining videos that I made. And if you want to finish that in a good condition, you just will have to do a bit more angles to see inside from the cylinder. It's quite the same like in other videos that I did on the topic. Just can give it another view on this side. Go a little bit up. To do the global registration, it's just to click that optimization button, and you will see that small misalignments that have been here as well are fixed up. I have no additional issues anymore, and of course I would need more rings to scan inside the cylinder to see the rest of the geometries. Here is the piece of tape that I have used for positioning the cylinder. I can just delete it and go to the project list. Here you have that advantage that you have the scans in groups. That means if you just want to delete a small part of one group, you are still able to do that in this group only and keep the rest of the data that you had before, not cut it away in the other group. So that kind of management of the scans is done quite logic. So I'm just going to re-show the other group, and I didn't delete that area where I scanned it without that tape roll, and I can go right now and, for example, mesh it. All that here, what you know, is the same like in the Transcan HX. I did even an update on that module, that the software module is the same. You can go watertight or unwatertight. Use the filter, look at the video, it's all the same, no problem. Just click on apply and it's going to be meshed. So you see, actually in a standard condition, if you even spray that part, I didn't even spray it, you are able to generate a scan of a part that's matching on the table by just, let's say, a few views, turning it around, and you will be absolutely fine with your results. So it's a lot easier to scan turntable parts like that based on that scanner. So I'm going to measure data. The menu that you've seen there is quite the same that you already know from the Transcan HX. No big difference. So, and I think this is a pretty decent result for a few scan rings, no manual adjustments, no stitching of data, nothing. And of course, if you want to scan all the areas perfectly, you will have to do more rings. But this is just the first overview what is possible within Transcan C, and I think this is a really good project. You will maybe really see more benefit if you will see the capabilities of texture capturing. What is a 12 megapixel texture capturing for each camera possible? And if you are, let's say, running, for example, a 3D printing business, imagine how fast you can do for your customer a verification of the print quality that you did and prove that your tolerances for dimensions are really good. I think this is really useful, and I will do further content on that scanner later on, from post-processing and so on. Nothing really special, you know all that from that Einscan H videos. If not, just take a look at the last one that I did on the software update, and stay in line for the next video with more stuff about the Transcan C. I think you will really like it. See you next time. Bye guys.